This is R.D. Sharma solution, class 12th. Differentiation chapter 11 exercise is 11.3. Y is equal to cot inverse. There is a content inside. You have to show that dy by dx is independent of x. This we'll talk later because you'll see the answer will not contain x. The basic thing is you need a cot here. Tan also can solve the problem, but preferably it should be cot. Alright? So we need to rationalize it. So in order to make you understand, let me call it as P. This as Q. 1 minus sin x is Q. 1 plus sin x is P. So under root P plus under root Q, that is divided by under root P minus under root Q. Okay? In order to rationalize, you have to multiply the numerator and denominator by under root P plus under root Q, because we need a squared minus b squared kind of thing in the denominator, so that we get rid of the roots. So we are multiplying this, rationalizing it. The numerator will be as under root P plus under root Q whole square, and this a plus b, a minus b kind of thing, it will be a squared minus b squared, that is under root P whole square minus under root Q whole square. So ultimately you will get P minus Q. And what is P? P was 1 plus sin x. And what was Q? It was 1 minus sin x. Now let us open this. 1 plus sin x minus 1 plus sin x. You can cancel these two. So the denominator will be 2 sin x. So we'll use this denominator in a short while. Let us resolve the numerator first. So it is under root P plus under root Q whole square. A plus B whole square. So under root P whole square will be P. That under root Q whole square will be Q. And that's twice of under root P into under root Q. So P plus Q plus twice of. So this under root P into Q, that we will just solve. P plus Q is what? 1 plus sin x plus 1 minus sin x. This is P plus Q. And plus twice of under root PQ, I will just do it. So this 1 minus sin x and 1 plus sin x, let us multiply this. P was 1 plus sin x and Q was 1 minus sin x. So you get a squared minus b squared, 1 square minus sin square x, and 1 square minus sin square x, 1 minus sin square x is cos square x, because cos square plus sin square is 1. So this under root cos square it is. Final will be cos x only. So this gets cancelled. You have 2 plus twice of cos x. And remember, what was the denominator? It is 2 of sin x. Twice of sin x. So let us write it here. Twice of sin x. Now 2 you can take out. 1 plus cos x. And denominator you have 2 sin x. 2 gets cancelled. 1 plus cos x is 2 cos square. Whatever theta is there, it will be theta by 2. So it will be 2 cos square x by 2. And sin x is sin theta, sin 2 theta is 2 sin theta cos theta. So here it is 2 sin x by 2 cos x by 2. Cos cancel, 2 cancel. It will be cos x by 2 by sin x by 2, which is equal to cot x by 2. So we have cot x by 2 here. Cot inverse was already out. So you can just cancel it out. It will be x by 2. So this is why dy by dx is simply half will be here. D by dx of x is 1. So the final result is half. That means that it is independent of x. Differentiation is independent of x. There is no x here. Okay. If you remember, this kind of question we have already done. And so this kind of question we have already taken. I am just skipping it because you know how to do this. For your reference, I am giving you the solution, so that you can do it one more time. This is also, this sec inverse has to be made as cos inverse, and sin inverse theta plus cos inverse theta is simply pi by 2. This already we have done. Just for your reference again, I am giving you the solution here. So we have to find out dy by dx, and that will be 0 here in this case. Sine twice of tan inverse. under root 1 minus x divided by 1 plus x. This under root is total, okay? It is both the num and den, that is numerator denominator, are inside the under root. So what do we take? Because we need a tan inside, okay? Just see the content. So if we put x as cos 2 theta, what do we get? 1 minus cos 2 theta divided by 1 plus cos 2 theta. This is 1 minus cos 2 theta is simply 2 sin square theta. 1 minus cos 2 theta is 2 sin square theta. And 1 plus cos 2 theta is 2 cos square theta. 2 gets cancelled. It will be tan square theta. Since it is inside the under root, it will be tan theta. And as I told you earlier, what do we need? We need a tan theta, of course. So you have sine twice of tan inverse, and then we have tan theta. Now you can just cancel this tan and tan inverse. So what is theta? So we have sine twice of theta. Theta from what we have substituted x is cos 2 theta. So this will be cos inverse x is twice of theta, and theta will be equal to cos inverse x half of cos inverse x. So you have sine twice of theta is half of cos inverse x. So 2 you can cancel, and you have sine of cos inverse x. Now you know that there is a relationship between cos inverse and sine inverse. What is that? Cos inverse x is equal to sine inverse under root 1 minus x square and vice versa. That is, cos inverse theta or cos inverse x is equal to sine inverse 1 minus x square. Alright? So the same thing with these, if you want to substitute it for other questions also, same kind of equality exists. So you have sine, in place of cos inverse x, replace it by sine inverse under root 1 minus x square. Now you can just cancel these two out. They are just inverse of one another, so you can just cancel them out. Okay. Now, what do we get here? Under root 1 minus x square. Y is under root 1 minus x square. So you have to differentiate this. It is simply 1 minus x square to the power half. So it will be half 1 minus x square to the power half minus 1. Half minus 1 is negative half only. So 1 minus x square also will be differentiated because of the chain rule. It will be minus 2x. So what do you get? Half. This will be negative half. So this, when you take it in the denominator, it will be 1 minus x square to the power minus half. Will become plus half. So that is root only. So 2 gets cancelled. You have minus x divided by under root 1 minus x square. Okay. Y is equal to cos inverse 2x plus twice of cos inverse under root 1 minus 4x square. X is between 0 and half. This is dy by dx, you have to find out. So first we'll try to solve everything. We'll come up with a solution. And then I'll tell you whether we are correct or not, because the range is given. 0 to half x has to be. So we need a cos here. We need a cos inside. Here also we need a cos. Both sides we need a cos. Okay. So let us take this. We'll check just this x between 0 and half. We'll just check in a short while. So we'll put 2x as cos theta. When we put 2x as cos theta, it will be cos inverse cos of theta twice of cos inverse under root. Now 1 minus 4x square, let us take this. 1 minus 4x square can be written as 2x square, and 2x is nothing but what? Cos theta. So it will be under root 1 minus cos square theta. 1 minus cos square theta is sin square theta. And under root of sin square theta will be equal to sin theta. Alright? So you can write it as sin theta. But in order to cancel these two, you need cos, this sin in terms of cos. Because cos 90 minus theta is sin theta, sin 90 minus theta is cos theta. So you can replace this sin theta by cos pi by 2 minus theta. So let me cancel these two first. Cos and cos inverse gets cancelled. I'll tell you the limits just now. So it will be theta, and sin theta we are putting it as cos pi by 2 minus theta. So cos cos inverse you can cancel, plus 2 into plus twice into pi by 2 minus theta. So that will be 2 pi minus 2 theta. So we have 2 pi minus theta. Final will be pi minus theta, sorry. So that will come, but we'll just see. So here you will get 5 pi by 2 minus theta. So you have to check for two things. The theta is correct or not, and pi by 2 minus theta is correct or not. And for sine or cos, you know, cos and cos inverse can only be cancelled when you have the theta belonging to 0 to pi. So what do we get here? Let us solve this first. So you have pi minus theta that you have to differentiate. Y equals to pi minus theta. Pi minus theta will be equal to what? It will be cos inverse 2x. So put it here. Cos inverse 2x. Because 2x was already taken as cos theta. Now before we actually differentiate it, we have to check for theta and pi by 2 minus theta. X is given between 0 and half. 1 by 2. Now, what is the value? 2x it is. So you have to use 2, multiply 2 everywhere. You get 0, 2x, and 2 into 1 by 2 is 1 only. So cos theta will be equal to, is between 0 and 1. So if you take cos inverse, this 0 will be 0. It will be theta, and this will be equal to pi by 2. So theta is between 0 and pi by 2. Don't worry about that, because we need to have just 0 and pi. Theta belongs to that. So 0 and pi by 2 is inside 0 and pi. Now pi by 2 minus theta. So when you have minus theta, see, we'll use just this result. Because theta is between 0 and pi by 2. When theta is between 0 and pi by 2, let me write it here. 0 is between 0 and pi by 2, inside we have theta. Now you need pi by 2 minus theta. So let us multiply everywhere with negative 1. So all the inequality will change. Minus theta, here also minus pi by 2. Now we need pi by 2 minus theta, so just add pi by 2 everywhere. Pi by 2 you add here also you add pi by 2. Okay, this is pi by 2, this is going to be pi by 2 minus theta, and this is going to be 0. Again, pi by 2 minus theta is again in between 0 and pi. It is between 0 and pi by 2, and we needed it for 0 to pi, and then that is also correct. Now let us take dy by dx. Pi will be 0. Cos inverse 2x will be, you know, cos inverse 2x, cos inverse theta is actually minus of 1 by under root 1 minus whatever is after the cos inverse, right? So you have two negatives, one negative outside, one negative coming from the differentiation. So minus 1 by under root 1 minus 2x whole square. So then the differentiation of 2x will give you 2. So minus minus plus twice of under root 1 minus 4x square it will be. This is your dy by dx. This is your final answer. Okay.